Hello, welcome to today's First Chesapeake Chat session. I am Rose Young, the FTC Team Liaison and Community Outreach Contact for First Chesapeake, and I'm here to introduce the First Chesapeake Chat sponsored by Newport News Shipbuilding. I would like to thank this session's sponsor for making this chat possible. And let me just go over a little bit of housekeeping. We will let the speakers present and then open the discussion for questions later on if there is time. Please feel free to put questions in the comments throughout the chat, and we will try to get to them all. The session today is presented by two FTC teams, and they're going to introduce themselves. But I wanted to thank Lincoln and Timmy for putting all this together, and they'll share with you their experiences as FTC team members over the past few years. They're also backed up by another team, 50/40. It said 50/50, but it's actually 50/40 from Ohio that had given some input into this. So really appreciate all of the support from all of the teams that wanted to come to you and share this important topic today, which for those of you who may be just starting out and you're not quite sure what this is all about, let's think about this. If you don't put the chassis on the ground, if you can't get the wheels turning, it's pretty tough to play most of the games in First Tech Challenge, right? So we wanted to start with this topic because this is so important. All right, so I'm going to pass it over to Lincoln and Timmy to introduce themselves. They'll share some contact information, and they've got a really nice presentation for you. So take it away, guys.
All right, thank you. Hello, I'm Timmy, captain of 4634 Frogbots.
I'm Lincoln, the hardware lead of Team 7393 Electron Volts. This is my 4th year on the team.
So today we're going to talk about chassis. Now the first question is, what is a chassis? Well, the chassis is a supporting frame of a structure of an appliance, like a car or even a toaster. Now remember to please put your questions in the Twitch chat and we'll answer them later. Here is an example of a car chassis on the left, and on the right is a forklift mech wheel drive chassis. Now the cool thing about this chassis is the mobility of the forklift to be able to allow you to go into and it allows you to go in all directions. It really helps.
So we've explained a little bit about what a chassis is in general, but how does that relate to FTC? So let's talk about that. Right here, I have a chassis I built for some prototyping that our team is doing, and what it's doing, it allows you to move around the field with these wheels, and then it also allows mounting of your mechanisms to your movable structure here. So I can move around the field, and then I can also mount my mechanisms here. So this is on a rotating mount here, so that I can angle the ring shooter here. And you can see that mount right there. Yeah. This is just a little prototype, but that's the concept. You're mounting your mechanisms to your structure and then having it move around.
So here's two examples of two back wheel drive systems. These simple bases can be built with parts that come from the FTC kit, and it is a really good base for rookie teams to learn from.
So actually, can we go back for a second?
Yes, go for it.
So the chassis on the left there was built by one of our rookie members. We sent them out a kit, and that is the first chassis they've built with just a few available parts. So it was an awesome start. Then let's talk about Mechanism Drive. That's what you saw in the example chassis I have here, but also you see that up on the screen. You can see that it's moving around the field in somewhat odd ways. If you haven't seen this before, it's moving sideways and it's turning in place. That's what's known as Holonomic Drive. It allows you to move from point A to point B on the field in one motion. It can even be a curved path. You can even turn while doing it. But Holonomic Drive, that's the concept there. You can move around, a lot of mobility, but it's a little bit more complicated and requires 2 more motors than the Omni-Wheel Drive. This can be built from kits, like the Gobilda kit you see on the right there, and it can also be built from more complex custom bases.
Speaking of custom bases, here we have two custom bases. On the left was a base built by our rookie team last year, and on the right is 4634 custom CNC drive base that we still use today. Now, custom bases can be just as good as stock parts, but some of the advantages, like adding hole patterns to the side for easy mounting, or putting hex shaft in the wheels to help with slippage, uh, can really help. Notice that both of these bases are A-frame bases to allow for easy intake options.
So we've talked about types of chassis, but then we want to know how do you choose which chassis to use? And it depends on the year, it depends what obstacles are on the field. So, for example, let's look at relic recovery. Get to that. In relic recovery, you had two main chassis-related tasks. Moving in a very confined area, getting those glyphs and putting them into the crypto box. And then you also had to balance on these platforms that were only supported in the middle. So you had to balance on the platform and get it to stay level. And Timmy has a story about that.
So in 2018, we had a Mecton wheel chassis, and because we had Mecton wheels, it actually slipped a whole lot on the balancing stone. So at MTI, we took 30 seconds balancing in finals. But moving on to last year's challenge. What do you notice about the field that's related to a drive base? First, the center plate, which your drive base has to be able to go over. This provides a minimum clearance requirement to the bottom of your robot. That may be all the things on the floor, but what else? The sky bridge. It provides a height limit. You may say, well, that doesn't have to do anything with the base. The lower your base is, the more room you have to put subsystems above it. So it does have to do with it. Now, this challenge from a while ago, you can probably see a lot of the requirements. First, climbing the mountains. You need to be able to get over those bars on the mountains, which provides a chassis requirement. And then the minerals on the field, you have to be able to go over them or push them aside without getting them stuck underneath your robot. And now for this year's challenge. There's no obstacles on the field for your base to go over, other than the rings. So what design should you build? What should you focus on?
So we've asked you that question, but we want to hear your questions. This was a very brief introduction to chassis, but we want to clarify things for you. So let's go into some tips and tricks about various chassis building techniques.
Yes, and if you have any questions, post them in chat, and now is the time that we will answer them. So a tip that I've definitely learned over the years is to Loctite your screws on your drive base, because sometimes, the screws are really inside your drive base and you don't want to tear apart the entire drive base of the competition. So it is a good thing to Loctite your screws inside your drive bases so that you don't have to dig through them in competition.
Yeah, for sure. Set screws, they come out a lot, and then your wheels end up falling off. Another thing, when you're using set screws, you also want to use D-shaft hubs. Look for those at your hardware vendor so that even when your set screw does come loose, even if you Loctite it, it might still happen. You can still get power transfer to your wheels. You can keep going for that match, even if something messed up.
So here's a question. How is 2 motors as good as 4 motors? Or is it? Lincoln, do you want to do that one?
Yeah, so 2 motors, you're going to have probably a setup like either tank drive, which is 2 powered wheels on each side, or you're going to have the omni wheel drive that we're going over. Do you want to go to that slide? So those 2 motors, you're going to be able to do certain maneuvers like moving forward. You can turn, but you have to turn while moving. If you can imagine, you can't turn in place. You can't simply rotate around the center of your robot, you have to rotate around where those motors are, or where those wheels are, where the motors connect to the wheels. So if you have 4 motors on each wheel, and then you also have those special mechanism wheels, you can have a lot more maneuverability.
Okay, so we do have a question from chat. So they want to know if they can push their chassis all the way out to the 18-inch limit, or would you recommend staying a good amount under that size constraint? So I would actually recommend taking your base to like 17 inches at the max, maybe a little bit smaller, so that way you can mount some things on the outside of the chassis to maybe like an intake or something like that. You want a little bit of wiggle room on the outside of the chassis. And another one in chat.
Yeah.
What are the advantages and disadvantages of a mechanism wheel drive base? Do you want to do that one?
Yeah. So advantages are the mobility. That is definitely a huge advantage. You can move anywhere on the field. You can rotate however you want. But it is a lot harder for years like what was it? First Rescue, where you have to climb up that mountain and you have to get over those bars on the mountain. When there are a lot of obstacles, mechanism wheel drive is hard to get over those obstacles and move around. So you'll actually end up having less mobility.
So a lot of it depends on the year and the challenge. As we said, you want to look at the challenge, examine the challenge, and find out what drive base is best for that year. Because say next year we have a moon, I don't know, kind of terrain with a whole bunch of huge craters. That's not the best for a mechanism wheel drive because it'll slip on the mountains.
Yeah, for that you would want something like tank drive or 6-wheel drop, where you actually have 2 powered wheels at the center of your robot and your whole robot pivots on those a little bit. And then there are 4 wheels on the outside. Actually, do we want to get a picture of that?
I don't know. So another thing that we can talk about is supporting your axles on both sides. Especially with a heavier robot, I would suggest supporting your axles on both sides to make sure that the axles don't bend. In Velocity Vortex a couple years ago, we had 6mm axles under a 42-pound robot, and because it was so heavy and wasn't mounted on both sides, the axles kept on bending, and we'd have to pull one out and replace it during the match.
Yeah, I actually have had our team has had the opposite experience. We've actually been able, for example, on this robot right here. Oh, that did not work. Okay, on the robot that I was showing off, we actually mounted the wheels directly to the motors. Normally, you wouldn't do that, but our robot was light enough and we had strong enough motor shafts that we were able to do that. So it depends. But for the most part, you do want to support them. Yeah.
And we actually, on our newest drive base, we actually use belts there because belts are a whole lot smoother, and with chain, you get a little bit of slop that you have to adjust for in the code. So we really like our belts on our new drive base.
Yeah, I hope that answers your question.
Are there any advantages to chain or belt drive? I think I just comment yes.
Yes. Yeah, so chain drive, you might be able to get more torque, but when set up properly, belts are going to give you the same performance, especially if you're FTC. You're not going to need that much torque. It's just a little more accurate, a little less slop, right? Yeah.
Although I really like our belts. Our belts are awesome. What is a good kit to start with for beginners? It depends on the parts you're using. So I use our team uses Actobotics, so they have an FTC starting kit that'll just give you a lot of the basic parts, screws, nuts, channel bars, wheels, stuff like that, and then you can expand off of that to get more mechanism wheels, to get motor. It gives you some motors, but different kinds of motors. So I think that's a good kit to start from, and then you can expand off of that.
Yeah, and there's another decision that you might want to make when deciding what kit to go with. Does your team like metric or imperial measurements? So Gobilda is a great metric kit and sort of set of stock parts. while Acrobotics is more imperial.
Yes.
Let's see.
So another thing, we mainly use 20 motors. I don't know what the proper name is. It slipped the top of my head. And 4-inch wheels. What motors should you use on your drive base? So yes, we use 20s with 4-inch wheels. It's about what you could do. If you really wanted, you could make the wheels smaller, the motors larger, and get the same amount of stuff. But mainly, we use 4-inch wheels and 20s. We've used that for the past many years. It's an Everest 20. That's correct.
If you want to go a little more advanced and you're willing to use a little bit more power on your drivetrain, you can actually make that faster using gearing, not necessarily gears, but different sized belts and or sprockets, and you can go down to even 15-1. So the Everest 20s are 20-1. You can even go down to 15-1 if you want to go extra fast. Is there a way to combine kits? Let's pull that up.
You can combine kits from, like, if you bought a Gobilda kit and bought an Activotics kit, the hole patterns don't quite line up, so you're going to have some mechanical problems, figuring out that. There are, I know at least from Tetrix to Activotics, there is conversion plates between the two. But I wouldn't suggest combining kits, but you can if you need to.
And there are some kits that are compatible, such as Tetrix and Gobilda. Tetrix has a 16 millimeter hole spacing, while Gobilda is also metric, so you can, on some of the holes, line them up. So yeah, it's not exactly compatible, but there are some of them that are compatible somewhat. Yeah. One tip for this year, if you want to go to this year's field, just an observation that could be made. Just like First Rescue, where there's a lot of debris on the field, that's what it was called at that point, the rings could get caught in mechanism wheels or other wheels. So you might want to design your chassis so that the rings won't slip under, or you can design a wheel guard around your wheels so that no rings slip under. Ooh, a weight limit. That's a great question.
So weight limit for this year. We don't actually have a weight limit like we've had for the past couple years at 42 pounds. Do I suggest a heavier or light robot? It depends on what you're going for. If you're going for speed around the field, you may want to make your robot lighter. But, if you want to make a sturdy defensive robot, heavy is actually really nice, especially for defense. So it depends on what you're looking for. What are the advantages and disadvantages of most common build systems?
Oh man, there are a lot of comparisons you can make. Let's see, what's a good example? Looking at.
So like a base build system.
Like let's say Actobotics. I think that's what you mean. So let's say you have an Actobotics kit. There's a very specific thing here. There's one disadvantage to Actobotics. They have some solid beams, and they have their other hole pattern, and they don't actually quite line up, even within their own system. Right. Tetrix versus Rev. Yeah, Rev. That's another one. Rev has a lot of advantages. They have linear slides that incorporate well with their entire system. It's metric, so it'll work with Tetrix and Gobilda, but it's also linear, mostly made out of linear slides, so you can actually attach stuff to almost any even custom hole patterns.
And then I'll talk for Actobotics because we use it. We really like Actobotics' hole patterns. Their axles are 1/4 inch. That's what we really, it's one of the things we like about them. Very easy to attach together. Gobilda, I really like how you can mount the motors inside the channel bars. We actually have a picture of the Gobilda, I think it's one of their kits, that shows their motors inside of the channel bars. I really like that design, and I wish Activotics could do that. But
Yeah,
I,
we
I
actually do
actually
that
haven't
too.
tried. I actually haven't
Um,
tried Gobilda's mounting stuff, so I don't know how that is.
I can speak a little bit for that. With this chassis right here, we actually have the motors inside the channels, and that has worked out really nicely. It just keeps it super compact. It's super easy to build with, and the motors are very high quality. So if you're going with that build system, then that's an advantage there. Any disadvantages for Gobilda? Let's see.
I don't know. I haven't used it. I want to at some point, but I haven't used it quite yet.
They're out of stock a lot because it's
a
so
lot of
popular.
people buy them.
A lot
Yes.
of people get it. The Gobilda mechanisms are a lot of times out of stock.
I've yet to try those. We've stuck with Actibotics because we haven't
Right.
made the decision to transfer to Gobilda. But
We
yes.
use I believe Robot Shop, or so we got our mechanisms from those. The Gobilda mechanisms are quite light, so your motors can move them very easily, and they just made new ones that are thinner, so they're even lighter. The ones we have are quite heavy. That has an effect.
I don't know what our mechanisms are called, but I mean, I got a base with them right here. But it's one
Those
of our
look like
old
the same
bases.
ones we have, just from a
Yes.
first glance. Yeah.
Also, I would not suggest using gears on your drive base. Chains work well, and gears are really hard to get right. So unless you want days of pain, I would not go for gears. But that's just a side note. Is there any more questions that y'all have in chat?
How do you prevent the rings from getting stuck on your robot? There are two types of getting stuck on your robot. There's possibly driving over a ring and it getting caught up in your drivetrain. That can be prevented with a wheel guard because the rings slide around quite well on the field. Then the other type of getting stuck on your robot might be if they fly down from the air from some other robot, or they bounce off of something and they land on your robot. So that's another thing to think about. That's not exactly part of the chassis. It's more of an enclosure for your robot, but you might want to think about that to make sure that those rings that land on top will slide right off.
Another thing, I would suggest using D-hub. I would suggest using all the D-hubs on your axles with the D axles, because even if the set screws are loose and they fall out or something like that in the middle of the match, because it's a D-hub, it'll still be in the wheel and it will still rotate even if it's a little loose, so you can still drive around instead of a rounded axle, which will just keep on spinning.
Let's talk about something real quick. Let me get this up. Where is it? Should be this. H drive is something very interesting. This is just an example I found. H drive uses all Omni wheels. Now there are some upsides and downsides to this. This is a holonomic drive. You can actually move anywhere on the field using this design. But then, there's a downside to this, is that it can get pushed around. So there's not enough traction on the wheels in most cases, so that other robots, if they want to go and you're in the way, you probably get pushed around.
Yes.
And especially if you're just doing 2 motors for your drivetrain, then don't put all Omni wheels, because then your robot will actually slide back and forth freely.
Yes. So we actually don't use Omni wheel drive at all, and I've seen several teams use it successfully.
Yes,
but we
that's
don't.
true. But it's a little bit more difficult to implement.
How do you
Less
guys
common.
limit ESD? How do you limit ESD? So some of the ways of limiting ESD is you could do what Wizards.exe did, which is make your robot out of wood. I think that will really eliminate the ESD problem, just because it's wood. There's also, I don't know quite what they're called, the thing on the cables. If you want to
Ferrite
talk on
chokes.
ferrite
So-
chokes, you want to talk on that?
That is a way to reduce ESD affecting your electronics. I'm not too keen on how they work too well, but I do know that they help with that. I don't have a picture. I can pull up a picture here. It's a good one. There we go. So that's a ferrite choke right there. This allows your data to not be lost by a spark. But then you also might want grounding wires. You can't ground yourself to the field, but you can ground your robot using designated grounding straps. Certain products from Gobilda, I don't know if Activotics has something for that. And designing your robot not to be a capacitor. So if you have two metal plates and then something non-metal connecting them, you're going to build up charge, and it's a significant shock, or it might be. And then also certain wheels have more capacitance than others, and they might experience more ESD.
So the other thing, not quite on base and wiring stuff, but your phone placement also really matters. You don't want to put your phone inside of a metal box with a whole bunch of electricity, because it'll block out the signal. So if you can, try to put your phone outside of that box to help the connection.
And then the last tip we have is to not design your base and then design your components, but to sort of combine the two design processes. So you're designing your base and your components to fit with each other.
Yes. You don't want, say, you built a base and it's this specific thing, and then you build your subsystems and your subsystems don't work. So you change your subsystems, which takes the quality and performance down by, say, 50%. You really don't want that. It's probably better to redesign your base to fit these amazing subsystems.
All right. That's about it.
Well, I want to thank Timmy and Lincoln for being here this evening. I feel like your combined experience is really amazing, and I appreciate you sharing it this evening. I also would like to thank our sponsor, Newport News Shipbuilding, which has brought this presentation to us. We have a little bit more information to share with you. If you check on the website, there are some really fun things for teams, not only about the chassis building, but about the game. And we're going to be sharing some links to some of those things. There's a follow-on session to this. And I hope that you'll stick around for that, because I think it'll be something that's really important, valuable for teams, just like this evening was. So thank you, Lincoln. Thank you, Timmy, for putting this together and for sharing. And thank you for all your team members that backed you up, and for Team 5040 that also backed you up. We had your contact info was on your last slide.
Yes,
I believe.
if you want to throw that one up, we do have our contact info. For them, it's a website link that has a whole bunch of different ways to contact them. And for 4634, if you contact us at info@frogbots.net, we can get back to you your email.
All right. So representing First Chesapeake here this evening, we really appreciate Electron Bolts and Frogbots for doing this little show for you. Thanks, guys. We have a short video now from our sponsor, Newport News Shipbuilding. And stick around and have a great rest of your day. And also stick around for the next chat, because it's going to be something that you're going to want to learn about. And please come back every other week, second and fourth Thursdays. We're here, and we've got some great stuff to share with FTC teams. Thanks a lot. Have a good evening.
See ya.